Okay, now let's look at how to select the element. To select an element from the vector or matrix using NumPy, we need to have the index corresponding to the desired element. Okay, and in Python, the index start from 0. So let's see the example and create one-dimensional array. So first of all, we are creating one-dimensional array, which is the vector we already discussed. Vector is nothing but the one-dimensional array. And to create the vector we using numpy dot array function, and the element of this array is 1 to 5. Now let's say we want to select the specific element from our vector. In this case we are interested in the third element of the vector. I told you the indexing in Python array start from 0, so the third element will have the index of 0. So suppose if we have vector have 5 element, so the one will have index of 0, second will have the index of 1, and so on, right? So if we want to select this third element, then the index of this third element will be the 2. In order to access the odd element, we just write the vector name, right? In our case we have stored this vector in a vector variable, and then open the square brackets and pass the index of the element which one we want to select. So let's, if we want to select the third, we just simply pass the index which is the 2, right? So if I run this cell, you will see it will select the third 3. So as you can see, because 0 is present on 1, 1 on 2 is present on index of 1, and 3 is present on index. So now let's take a look at that how to select the element from the matrices. We already discussed that matrices are two-dimensional array that contain rows and columns. So let's see the example. So here we are creating a 3 by 3 matrix using numpy array function. Each of the rows is enclosed in square brackets and the elements are separated by the commas. Now let's say we want to select the element from our matrix, and here we are interested in the second row and in second column. Again, Python indexing start from 0. So to access the second row and second column, we will use the indices of 1 and 1. So again, we will just pass the name of the matrix and then open the square brackets and pass the index, right? So by using 1 and 1, we assessing the element at the intersection of the second row and second column, which has the value of 3, because we this present in a second on first index from rows and first index from columns. So if I run this cell, you will see select the third element from the matrix. So in NumPy, there is a varieties of method for selecting the element, like indexing and slicing. So let's see the example for it. So in this example, again we are creating one vector using the numpy.array function, and our vector contain the value 1 to 5. So now let's say we want to select all the element of the vector. So we can achieve this using the slicing notation and the colon inside the square brackets, right? So this is the shorthand for selecting all the element, right? So if we run this cell, you will see this colon will select all the element that is present inside the vector. So let's see and run the cell, and as you can see here, it's print all the values by selecting the element from the vector. So now let's see more example with slicing. Suppose we want to select everything up to and including the third element of our vector. We can achieve this using the slicing notation again, and we just pass the semicolon and then specify the range of the element that we want to select. So in our case, by using the vector colon t, we actually specifying that select the element from beginning up to the including the element at index of 2, which is the third element in the Python. So our slicing vector will contain the value from 1 to 3, because this is the vector, and 3 will basically specify the value, and 3 will have the index of 2. It will select all the value from beginning to the 3. So as you can see, the value is present 1, 2 and 6. Similar, if we want to select the everything after the third element of our vector, so for that we use colon and after the number, and it specify all the value starting from the index and onward. So here we are selecting all the elements starting from the element at index 3, right? And which is the fourth element in Python, because the index again start from 0. So our slicing vector will contain the element 4 and 5, which is everything after the third element. So run this cell and see. So as you can see, it select the 4 and 5 value from the vector. So let's move further and see the negative indexing. Suppose we want to select the last element of our vector. To achieve this, we can use negative indexing. In negative indexing, we specify the index of the element we want to select relative to the end of the array. So -1 represent the last element, and -2 will represent the second last element of the vector, and so on. So in our case, we have used vector, and in square vector we have passed the -1, and here -1 will basically select the last element of our vector, which is the 5, right? So let's run this cell, and as you can see, it select the last element. If I pass the 2 here, and you will see it will select the 4. So as you can see here. So now let's see how to reverse the order of the element in our vector. Order of our vector is to reverse. We will use slicing notation with the step size of -1. As you can see, first we will specify the columns and then specify the -1, which will basically reverse all the values. As you can see, in our original vector, the value will start from 1 to 5, and in reverse value will be start from 5 to 1. So let's run this cell, and as you can see, it has reversed the order of our matrix. Now let's see the slicing notation for the two-dimensional array or matrix, because matrix are nothing but the two-dimensional array. Suppose we want to select the first two rows and all the column of our matrix. So for that we will specify the colon, and after the column we specify the number of rows, and then a simply colon, we already seen it means a simply colon. If we place it, mean we want to select all the things. So in our case, we want to select all the columns, because in matrix first we represent the rows and then columns. So it will select first two rows and then all the columns. As you can see, it will select two rows and three column, mean all the columns. Similarly, if you want to select all the rows and specific column from the matrix, then we will use simple colon in order to select all rows, and then specify the range of the column that we want to select. So if we only want to select the second column and all the rows, and if I run this cell, as you can see, it has select the second column and three rows. So if I show you the matrix, and this is our matrix. So now let's move further and see how to find and select the maximum value and the minimum value from the matrices. To select minimum maximum value, NumPy has a function called max in order to select the maximum value, and min in order to find the minimum value. Suppose we have this matrix. So if I run this cell, and then if we want to select the maximum value, as you can see, the maximum value in our matrix is 9 and the minimum value is 1. If I run this function np.max on this matrix, it will basically select the maximum value, which is the 9. And if I run np.min function on this matrix, it will select the 1, because there is the minimum value is 1. And now let's explore some basic statistical operations that we can perform using the NumPy on arrays. So the first, we will calculate the average, which is the mean, in simple term, variance and standard deviation. So again, we are creating one matrix using the numpy.array function, and this matrix has 3 rows and 3 columns, 3 by 3 matrix. And I store this matrix in variable called matrix, and NumPy again have one function called np.mean, and if we run this np.mean function on this matrix, it basically return the average value of the matrix. So the mean is simply the central tendency that represent the sum of all the element and divided by the total number that is present inside the matrix. And we can compute by using this dot mean function. If I run this cell and this one, and you will see the average of the values. And next we will calculate the variance, and variance is simply measure the spread or dispersion of the data points around the mean, and it indicates how much data is deviate from the average or deviate from the mean. And we can simply calculate the variance by using p.var function and pass the matrix to this function. If I run this cell, you will see the variance of this matrix is 6.66 and so on. And the third basic statistical function is deviation, and simply called standard deviation. Standard deviation is used to quantify the amount of variation in our data set. So if we want to compute the standard deviation, we just simply call np.std, which basically stand for the standard deviation, and pass the matrix to this function. And if I run this cell, you will see the value of the standard deviation of this matrix, which is the 2.5.8. So now let's see the another operation, which is the reshaping the array. So in order to change the shape or transformation of the dimension of an array without changing the element value, for that we will use the reshape function. And let's see the example. First we will create one matrix which is the 4 by 3, because it has the 4 rows and 3 columns. And then we will run this reshape function on this matrix and specify the dimension in which we want to transform our original matrix. In our case, we want to transform this 4 rows into the 2 rows and 3 column into the 6 column, right? So it will basically convert the dimension from 4 by 3 to 2 by 6. And then after reshaping, I store this matrix in a reshaped matrix and print the matrix. And if I run this cell, you will see it has 2 rows and 6 columns. So we also have one special feature known as auto dimensioning. By applying the matrix dot reshape 1 into -1, we basically instructing the numpy to reshape our original matrix into the one dimension, right? And with this, the size of the second dimension automatically calculated based on the total number of element that is present in our original matrix. And this basically flatten our all the dimension into the one dimension or in a single row. So if I run this cell, you will see it flatten our matrix into the one single row from 1 to the 12. So now let's see the transposing of the matrix or vector. In transposing, we simply convert the rows into columns and column into the rows. For that, we will be use simple transpose dot t function. T stands for the transpose, and it simply convert the rows into column and column into the rows. If I run this matrix and then run the transpose function on it, you will see this row which is 1, 2 and 6 converted into the column, and the second row converted into the second column, and the third row converted into the third column. So we also run this transpose function on vectors. So for that, we will just simply create one vector and then run the t function on the vector to transpose the, in order to taking the transpose of the vector. If I run this cell, you will see it transpose one row into the single column. So there is an other way to flatten the matrix in NumPy, which is the flatten function. Let's see. So first we will create one matrix, and by using numpy.array function, and then we will run the dot flatten function. By applying this matrix dot flatten function, we flattening our original matrix into the one dimensional array, and it basically iterate over the element on the matrix row by row and arrange them into the single row. Alright, so first I run this cell, you will see it will basically transpose them into the single row. So as you can see here.